Have you ever wondered about the real benefits of mounting radio antennas high up on towers, on buildings, or on other forms of mast? There's a real cost to this, so is it really worth it, and does it bring the benefits to warrant the cost, especially for frequencies in the VHF and UHF portion of the spectrum? In this video we're going to describe why antennas are mounted high up and also explain in more detail the benefits of seeing why antenna height is important, especially at VHF and UHF. The same principles hold true for HF radio, but there are other factors that come into play, so for this video we wanted to focus on antenna height at VHF and UHF. And also in this video we'll give you some essential hints and tips when you want to mount your antennas higher. As we see all around us, domestic television antennas are placed high up for the best reception. Antennas appear on houses, often fixed to the sides of the house, to chimney stacks or other convenient places. People wanting to receive terrestrial television signals will often want to put their antennas as high as reasonably possible for the best reception. Not only are television reception antennas mounted high up on the tops of roofs or houses, but other types of antenna are seen high up. We're all used to mobile phone towers. The antennas themselves are mounted reasonably high up. They appear in all sorts of places, often becoming very easy to see, and in some places they might be considered to have an adverse visual impact. They can be on towers, as part of poles by streets. They can even be on the tops of buildings. We see them in towns, in the countryside, in fact all countries around the globe. In fact, anywhere that mobile phone reception is needed, we see these towers. Radio and television broadcast transmitters also tend to have their antennas mounted on high points and on high towers as well. The cost of installing them and then maintaining them must be enormous, so there must be a good reason, and we'll look into what this is. Other types of radio antenna can also be seen placed high up. These are used for all sorts of forms of communication. Again, there must be reasons for this, which we'll look into and explain. And don't forget our hints and tips later that might help you to get much better performance from your antenna. There are several reasons for placing antennas high up. It can provide a clutter-free line-of-sight path with nothing in the way. And antenna height also enables the horizon to be further away, so it's possible for the signal to travel further. If there are hills around, this can also be an issue, and having the antenna high up can sometimes improve the radio coverage. Let's investigate these reasons further to understand why and how this can be applied to your antennas. First, let's look at the signal path when the antenna is low down and the signal has to pass through plants, through buildings, and any other objects that may be in the way. Normally, for a line-of-sight path, as the distance between the transmitter and receiver increases, the signal falls away by a factor of 1 upon d squared. It's the inverse square law. This means that if the distance between the transmitter and receiver doubles, then the signal level will fall to a quarter. The inverse square law is fine where there's a direct line of sight, but if objects get in the way, then they will tend to absorb some of the signal and it'll be reduced or attenuated even further. A prime example of this is mobile phone users. We all don't select the best sites when we want to use our phones. We want to use them everywhere, and after all, they're called mobile phones. This can be in the streets, in homes, in fact almost anywhere, and there are bound to be all sorts of objects around us. Because of this, instead of using a path loss calculation where the signal falls by 1 upon d squared, planners often use a factor of 1 upon d to the power 3.5 or 4. So let's take an example of using 1 upon d to the power 4. We can show what a huge difference this makes. Rather than 1 upon d squared, we see that if the distance is doubled, then the signal drops not by a factor of 4, but by a factor of 16. This is huge. It's for this reason that mobile phone towers are put well above the ground, so that at least the base station antenna is in the clear. And of course this goes for all forms of communication, radio communication systems. It's very easy to see the effect of raising the antenna height. As the height increases, it's possible to see out beyond the houses, buildings and so forth, well into the distance. This effect will also be true for the radio signals. A factor which is particularly important for long distance coverage is the radio horizon. This is important for things like broadcasting or for point-to-point coverage, amateur radio and the like. It stands to reason that the higher you are, the further you can see. This short clip shows this quite well, even though the height increase was relatively small. It's found that the horizon can be calculated relatively easily using this equation. It's not exact, but it is more than accurate enough for virtually all calculations. The distance to the horizon is the square root of 2 times r times h, where r is the radius of the Earth and h is the height of the point above ground. It goes without saying that the variables must all be in the same units, and we'll be using meters. So if we have a point that's a metre above the ground, then the horizon will be 3.6 kilometres away. But if the height is raised to 10 metres, then the horizon extends out to 11.3 kilometres. This calculation assumes a spherical Earth with a uniform radius of 6,371 kilometres. Also, the Earth has many hills and mountains, so to gain extra height, radio antennas are often mounted on hills to give them extra height. We can see how it's possible to see much further from a local high spot, even on this frosty, misty morning. Often radio broadcast antennas make use of this, and they're located on high spots and also have high towers to get the very best coverage as we see here. Not only is the antenna tower high, but the view from the base is also very good. A further advantage is that the refractive index of the air changes slightly with altitude over the signal path. This tends to bend the signal around the Earth's surface so that it covers a greater distance. Often the radio horizon can be about 4/3 of the trigonometrical or direct line of sight distance. The hills and undulations in the Earth can also interrupt the signal path. Having a high antenna, both for reception and transmission, helps the coverage behind any of these hills. So it can be seen that having a high antenna can help in many areas, obviously for transmission, but also equally for reception. Raising the height of an antenna can give some significant gains. There are no exact figures because each situation is different, but in a smooth terrain it has been said that there is nearly a direct relationship between antenna height and signal gain. Doubling the height of an antenna could double the signal strength and so forth. So if you're suffering from poor reception, increasing the antenna height may well improve things. There are some other benefits as well from raising the antenna height. The antenna can be further away from sources of interference, and this can sometimes give significant benefits for reception where there is noise. Also, if the antenna is used for transmitting, the higher the antenna is, the further it is likely to be away from inhabited areas, and the risk of high levels of transmitted radiation is very much reduced. However, beware, as there are a few things to think about when raising the height of an antenna. Here are a few pointers and essential tips. It can become more difficult to maintain an antenna with a higher tower or pole. Also, higher towers or poles might be more subject to the weather and so forth, and antennas might be more exposed. Another point is that it will need a longer coaxial feeder or lead. This will introduce additional loss, so be careful to use low-loss coax so you don't throw away all the gains of raising the height of the antenna. So there it is, our short summary about the importance of antenna height. Thank you for watching, and if you need any more information, then head over to the description for the video, where there's some additional information and some useful links. Also, please don't forget to subscribe to our channel and like the video. Thank you.